Intro. I love science that feels like magic, but is actually just careful observation, clever engineering, and a little bit of patience. Today we're doing 4 rice hacks in the garden to test a claim that sounds too good to be true. Using rice products can dramatically boost earthworm numbers. Spoiler: the worms didn't read the memo, but they definitely RSVP'd. Over the next few minutes, I'm going to walk you through each method, show you exactly how I did it, and, most importantly, share the proof. We're talking counts, photos, data that actually tell a story. Chapter 1. Fermented rice water. Fermented rice water is literally the cloudy liquid left after soaking rice. After rinsing rice, the cloudy water is collected. Leave it to sit until microbes bloom, about 24 to 48 hours, until it smells lightly sour. Quick how-to: rinse a cup of rice. Collect the cloudy water in a jar. Leave the jar in a shaded spot for 24 to 48 hours. I diluted that concentrate 1 to 10 with water and applied it as a soil drench. The idea is you're feeding the microbial community. Bacteria explode in number. Fungi also explode in number. That microbial biomass becomes food for detritivores, and indirectly for earthworms. The biology is simple. Microbes multiply on the easy sugars, and starches leached from rice. Those microbes make organic matter more palatable, and they increase the microbial biomass worms graze on in the soil matrix. In my small plots, I saw a visible increase in surface worm activity within a week of weekly drenches. A 2018 study in Applied Soil Ecology reported rice washings increase microbial respiration rates. Similar trials in composting literature show short-term increases in microbial biomass. Chapter 2. Rice bran is the fine, nutrient-rich layer removed during milling. It's full of proteins, fats, and easily degradable carbohydrates. To apply it, I broadcast a thin layer about 5 millimeters over the bed, lightly incorporate with a fork or a shallow rake or top dress around established plants, let soil fauna work it in. Rice bran is a concentrated food source for microorganisms that supports higher trophic levels, nematodes, earthworms. In my plots, I saw steady increases in soil organic matter and worm biomass over a month. Rice bran contains nitrogen, phosphorus, micronutrients, and labile carbon microbes quickly metabolize. A field trial in soil biology and biochemistry found increased microbial biomass carbon and accelerated organic matter turnover. That aligns with vermicomposting studies reporting higher worm biomass. Experiment: matched pair design. Treated plots: 0.5 kilograms per square meter rice bran incorporated. Control plots: no bran. After 6 weeks, the bran plots showed richer, darker topsoil and more worm casts. I sampled with loss on ignition. Results: modest but measurable uptick in treated plots, consistent with faster microbial processing and bran incorporation into aggregates. Tip: less is more. Too thick a layer can create anaerobic pockets as microbes consume oxygen, temporarily depressing worms. Thin, even application encourages steady decomposition and worm attraction. Rice bran can be high in oil. Store cool to prevent rancidity. Use fresh material, not stale. Rice bran reuses a milling byproduct that often gets wasted. Locally cheap near rice-producing regions. Otherwise, mix small quantities into compost. I tracked the trial with labels, photos, soil color, smell, and worm frequency. Chapter 3. This is the gross but effective one. Cook plain rice. Let it cool completely. Stuff cooled rice into breathable mesh bags. Use 50% shade cloth or burlap-lined mesh. Bury shallowly beneath mulch or bury beneath leaf litter. The mesh concentrates a high-quality food source in one spot. It attracts detritivores, slugs, sow bugs, springtails, and earthworms following the microbial feast. Within days, I found clear worm aggregation around the bags and noticeable increases in surface activity nearby. The mechanism is concentration versus scattering. a bait creates a hotspot where microbes rapidly colonize the rice, creating a dense microbial and detritivore community that worms love. Results in my plots showed more worms per square around bait bags. Counts doubled in some replicates. Vermicomposting literature shows localized hotspots. Increase worm density and reproduction. Sanitation is crucial. Chapter 4. Rice hulls are the lightweight outer casing of the grain. Think airy, loose with great drainage. Spread as a 2 to 3 centimeter mulch layer, rice hulls increase aeration and prevent surface compaction, creating an environment worms absolutely love because it keeps the soil crumbly and oxygenated. In my trial, I applied hull mulch to half of several beds and left the other half with standard wood chip mulch. Over a month, the hull-treated areas showed more worm movement and surface casts, presumably because the microhabitat was cooler and better aerated. The physical effect is key. Worms need pore space and oxygen. Fine textured soils that are compacted or waterlogged discourage them. Rice hulls maintain pore continuity and promote faster water infiltration and drainage. Research in soil physical properties has shown that incorporating rice hulls or using them as surface mulch can improve soil porosity and reduce bulk density. For the experiment, I laid a consistent depth of hulls across replicate plots, monitored soil temperature, monitored moisture, monitored worm presence. Outro. After running these 4 hacks side by side, you can use rice products to create food-rich hotspots and better physical habitat. Fermented rice water gives a quick microbial bloom. Rice bran supplies concentrated nutrients. Cooked rice in mesh bags creates a baited aggregation. Rice hulls improve the structure and aeration they love. In my small replicated trials, I saw worm counts and surface activity roughly double in the most successful treatments compared to untouched controls. If you want one recommendation to start with, try a thin layer of rice hull mulch to improve aeration while pairing it with occasional fermented rice water drenches for microbial food. That combo balances habitat and nutrition without being high maintenance. Always start small, document what you see, and adapt to your microclimate. What works in my yard may need slight tweaks where you are.